Dear students, once again we are continuing with fourth topic of your syllabus known as feedback in amplifiers. In the last week we studied regarding the meaning of feedback, and where we have concluded that feedback is the process in which some part of the output or a fraction of the output is given back to the input. It might be going to be added to the original input to increase the gain, or it might be going to be subtracted from the original input to decrease the gain. And the amplifier that uses this particular principle, that is known as feedback amplifier. Mainly it makes use of the basic amplifier, whose role is to amplify the signal to the required level, and the feedback network. Its role is to feedback part of the output voltage back to the input. Depends upon feedback factor, whether it is positive or negative. Depends upon type of the fraction of the output feedback voltage, whether it is going to be added to the input or subtracted to the input. Accordingly, there are two types of the feedback. One is positive feedback and second one is negative feedback. Positive feedback is the feedback in which the feedback factor K is positive, or the feedback voltage is added into the original input so as to increase the gain. This is called as a direct feedback, regenerative feedback also. Basically, positive feedback concept is utilized in the oscillatory circuitries. Negative feedback is the type of the feedback in which the part of the output voltage which is feedback to the input, it is subtracted from the input so as to reduce the voltage gain. This is called as a inverse feedback, or it is called as indirect type of feedback. These are the two types of the negative feedback which we already studied. After that, we have covered concept of feedback. We have studied the concept of feedback by using the block diagram last time, which makes use of the input source, mixer or comparator, basic amplifier, sampling network, and the feedback network. We have studied the meaning of each block and the role of each block while studying the concept of the feedback. Friends, in this particular period, we are going to see some general aspects associated with the feedback under the title known as General Theory of Feedback. To study the general theory of feedback, let me consider the basic amplifier, which has an input voltage Vi before feedback. Basic amplifier amplifies that input voltage Vi and produces the output voltage Vo. Let me consider AV is the gain of basic amplifier without feedback, which is generally given as Vo upon Vi. But after feedback has been applied, let the new input voltage be Vi dash and new output voltage be Vo dash. Out of that Vo dash, some part of that, that is K times Vo dash, is feedback to the input, and that is done by means of an feedback network, where K represents the feedback factor. Let me consider AVF with a gain of basic amplifier with feedback or after feedback, which is given as AVF is equal to VO dash upon VI dash by the definition of formula of the gain. Then we are going to proceed further. Friends, when switch S is open, means no feedback voltage is provided to the feedback network, and that's why no feedback signal is given back to the input. Means amplifier works as an amplifier without feedback. Let Vi be the input voltage at that time, Vo be the output voltage after amplification without feedback. Let Av be the gain. Then voltage gain of amplifier without feedback is given as Av is equal to Vo upon Vi. But when switch S is closed, some part of the output voltage Vo dash is the new voltage. Part of that K times Vo dash, it is feed back to the input. Then we can say when switch S is closed, new output voltage be Vo dash and feedback factor fraction is K times Vo dash, where K is the feedback factor whose value is always less than 1. Value of K should be always less than 1, that remember. If K becomes equal to 1, entire voltage will be fed back to the input. But we are providing fraction of the output. To take the fraction value of K, that is the feedback factor, it should be less than 1. The new input to amplifier is Vi dash is equal to Vi plus K times Vo dash. K Vo dash is the feedback voltage. It is introduced in original input voltage. Therefore, new input voltage becomes Vi dash equal to Vi plus K times Vo dash, which is represented here. After amplification, new output voltage means when Vi dash is amplified, means Vi plus K times Vo dash, this is amplified. Then new output voltage is Vo dash, and that Vo dash is equal to gain times the input voltage. After amplification, the new output voltage Vo dash is equal to gain times the input voltage, that is Av into Vi dash. But we have Vi dash which I already calculated, and that is equal to Vi plus K times Vo dash. Putting this value in this equation, we can get Vo dash equal to Av into bracket Vi plus K times Vo dash. Simplifying the bracket, we can get Av into Vi plus Av into K times Vo dash. Transfer Av into K into Vo dash to the left side, so as to get Vo dash minus Av into K Vo dash equal to Av into Vi. Take Vo dash common. When you take the Vo dash common, we can get Vo dash into bracket 1 minus K times Av equal to Av into Vi. Take Vi dash to the left side, so that Vo dash upon Vi is equal to Av upon 1 minus K times Av. Where Vo dash upon Vi is the voltage gain after feedback, that is AVF. Therefore, AVF equal to AV upon 1 minus K times AV. AVF is the voltage gain, F is for feedback. So voltage gain after feedback, now it is given as AV upon 1 minus KAV. We can call it as the general equation of the feedback. Now in this general equation of feedback, if K is negative, then general equation becomes AVF equal to AV upon 1 plus KAV, because K is equal to minus K. This indicates that AVF is less than AV. Naturally. This makes you clear that feedback is negative If K is negative, then feedback is negative. And under that particular condition, after feedback, voltage gain decreases. Thus, we can say that when negative feedback is applied, voltage gain after feedback becomes less than voltage gain before feedback. Now, if suppose K is positive, then feedback is positive. When K is positive, then we can get AVF equal to AV upon 1 minus KAV, because K is positive. This is the general equation. In this general equation, we are substituting K is equal to K. So that's why equation remains same. That is AVF is equal to AV upon 1 minus KAV. This indicates that AVF is greater than AV. That is, after positive feedback, voltage gain increases. In this equation, that remember, this is the formula for gain after feedback if feedback factor is positive. In this particular gain of positive feedback equation, if suppose 1 minus KAV equal to 0, this is possible if and only if KAV is greater than or equal to 1. If KAV becomes equal to 1, 1 minus KAV equal to 0, then AVF equal to AV upon 0. AV upon 0 comes to be infinity. So that is, voltage gain after feedback seems to be infinity. When voltage gain becomes infinity, then amplifier is going to be converted into oscillatory circuit. Thus we get output without any input. Thus we get output without any input, that is known as the oscillatory circuit. Thus, to produce or to design the oscillatory circuit, one thing it is clear here only, and that is feedback must be positive. When feedback is positive and 1 minus KAV equal to 0, then amplifier circuit is going to be converted into oscillatory circuit. This particular aspect we are going to study in the next topic. Friends, thus if the negative feedback is applied, voltage gain decreases. If positive feedback is applied, voltage gain increases. If particular condition is satisfied, then amplifier circuit is going to be converted into the oscillatory circuit. That's all about the general theory of the feedback. Now friends, we came to know the meaning of positive feedback, how it is going to be resulted, and the meaning of negative feedback, how it is going to be resulted. If feedback factor K is negative, we can get the negative feedback. If feedback factor K is positive, then we can get the positive feedback. Friends, in this particular topic, we are now going to study the effect of negative feedback on the amplifier circuitry, on the operation of B.Sc-II as an amplifier. So that's why let me consider advantages and disadvantages of the negative feedback. Following are the advantages of the negative feedback. First one is increase in stability. Means due to application of the negative feedback, stability of the circuit increases. Our operating point becomes stable. That is the first advantage. Second one is increase in bandwidth. Due to application of the negative feedback, there is increase in bandwidth. Bandwidth rises. When negative feedback is applied, less amplitude and harmonic distortion, means harmonic and amplitude distortion decreases. Along with that, the phase and frequency distortion also decreases. In short, we can say the distortion decreases by applying the negative feedback. Next type of advantage is that there is a reduction in noise due to application of the negative feedback. One more advantage is increase in input impedance. If the negative feedback is applied, the input impedance of that particular amplifier will be more. Next advantage is that decrease in output impedance. Look at here. This is what the decrease in output impedance means. Negative feedback amplifier has got high input impedance and low output impedance. It has only one disadvantage, and that is it decreases the voltage gain, as we already studied just now. Friends, thus the voltage gain of negative feedback amplifier decreases with only this particular disadvantage. Remaining all are the advantages of the negative feedback. Friends, that's all about the general theory of feedback and the advantages and disadvantages of the negative feedback. Next time we'll go for next topic.